let's take a look at this first one, the bathtub problem. You pull the plug from the bathtub. After 40 seconds, there are 13 gallons of water left in the tub. 1 minute after you pull the plug, there are 10 gallons left. Assume the number of gallons of water varies linearly with time since the plug was pulled. All right. So in part A, they want us to write a linear model expressing the number of gallons left in the tub in terms of the number of seconds since you pulled the plug. Okay, so I'm going to make myself a little tea table. Okay, the gallons in the tub depend on how many seconds it's been running out for, right? Not the other way around. So I'm going to have seconds depending on, in fact, I put seconds, gallons. And this is one of the ones where they gave me 2 data points. They told me 40 seconds, 13 gallons. I just forget I gotta zoom out a little bit for the video. Okay, 40 seconds, 13 gallons. All right, 40 seconds, 13 gallons. 1 minute, there are 10 gallons. Right, be careful. You want your units to match. You're not going to put in a 1 because I'm dealing in seconds. So make sure you put in a 60 and there were 10 gallons left. Okay, great. I have 2 data points. Go ahead and write me an equation. Look up here when you're done and we'll see if we match. Oh, I always do that. Okay, do we agree? Do we all get the same equation for part A? So now I have this function written that models the water in the tub at any time. So in part B, they want you to answer the question, how many gallons are you going to have after 20 seconds and after 50 seconds? So all I have to do is take my equation that I wrote and then pop in for S, 20 and 50. Okay, so go ahead and do B, and let's see if we match. What do you think? Did you get what I got? Yeah? And also, you want to make sure that your answers are making sense. So if you envision this bathtub, 40 seconds there was 13 gallons, right? After a minute, I'm at 10 gallons. So if I'm doing 20 seconds, okay, so that makes sense because after 40 seconds there was 13. So if it's only been 20 seconds, I should have more than 13 gallons in there. And I do. I have 16. And then for 50 seconds, that's a little bit before the 1 minute mark, right? So I should have a little bit more than 10. And I do. I have 11.5. So my numbers are making sense. So far, so good? All right. Let's see. The next letter D over here says, find the y-intercept. What does this number represent in the context of this problem? Well, based on my equation right here, I know the y-intercept. What is it? 19, and what does that mean here? Yes. Exactly. So 19 is my y-intercept. And it's going to represent number of gallons in tub when plug was pulled. Right? Let's try C. At what time will there be 7 gallons left? Okay, so now I want to solve for the number of seconds, but I'm given the number of gallons. So, what am I going to do? Go ahead. That's it. Go right back to the equation that you solved, right? And then right here, I'm just going to plug in a 7 and solve for S. So let's see if we can get that. Let's see. Make sure whatever answer you get, check that it makes sense. Remember that at 1 minute there was 10 gallons left. So now I'm at 7 gallons left, so my time should be something bigger than a minute. Did you get 80? Okay, and that makes sense. 80 seconds. All right, let's try the next one. We have to find the X-Intercept. How do you find X-Intercept again? Yes, you're going to go right back to your equation and you replace y with 0. So instead of, like in the last one, I plugged in a 7 for y, now I'm going to plug in a 0 for y and solve for s. So same setup, just pop in a 0. I get 126 2/3 seconds. And what does that mean? What is this representing in this problem? Exactly. That'll be how many seconds until the tub is completely drained. Okay, so now we're being asked to graph this thing. So we've got time in seconds over here, water in gallons here. We have to come up with the scale. So let's just start with time in seconds. What's the smallest amount of time I'm going to represent on my graph? 0, right? I'm not going to have negative time, so it makes sense. Right here, I'm going to start on 0, sure. And then what's the maximum number of seconds I need to represent on my graph? The 126 2/3, right? Because after that, the tub is empty. So I need some scale. I need to be able to go at least, I don't know, if I say you did 130 would be fine. So I forget what I did when I did this. Oh yeah, I did by 20s, but you do whatever makes sense to you. And then I need to do the same thing for the y-axis, the water in gallons. So, same thing. I'm not going to have negative gallons, so the smallest I need is 0, but what's the max I'm going to need? 19. So, you count how you like. I did by 3s. And now I'm just going to graph this. You have an equation in slope-intercept form. So I know the y-intercept is at 19. So on my graph, that's right about there. I also know the x-intercept, 126 2/3. Right about there. I also have other points, right? I knew at 40 seconds I had 13 gallons. So just for fun, I'm going to sort of plot everything that I have. And at 60 seconds, I had 10 gallons. So it should all fall in a straight line, or pretty gosh darn close to it. Hey, not bad. And then the very last question about this problem, they want to know what is the slope and what does this represent in terms of the problem. So what's the slope? You know that from part A, right? The slope is -3/20. And what is that showing me, Bridget?
The rate of the water draining.
So I'm losing, how would you interpret this? I'm losing how many blanks per blank? 3 gallons every 20 seconds. Which is sort of a weird measurement. So it might be, if I really want to know, normally I don't measure things every 20 seconds. I would do, if I do the 3 divided by 20, it might also be helpful to divide that out and get a -0.15. So that would be over 1. So that shows me I'm losing 0.15 gallons per 1 second. Usually we like to measure things as a find its unit rate, right? How many per 1 second instead of 20 seconds is sort of a weird measurement. So I am losing 3 gallons every 20 seconds, or losing 0.15 gallons every 1 second. Okay.